So hello everyone. Let us understand uh, a few practice problems which are based on wave function, probability and expectation values, and these are the topics which are exactly being asked in the UPSC mains paper. So the first paper is to normalize the wave function, okay, which is given by psi, that is exponential minus modulus x sine alpha x. And question based on normalization has been asked previously, so we need to take a special care of it. So now let the normalized wave function be n times the given wave function, that is psi. So in because n is going to be our normalization constant, we know that, and because of this modulus function, we will have two different, slightly different wave function for negative x values and positive x values. For negative x values, it is going to be exponential x sine alpha x, and for positive x value that is going to be exponential minus x sine alpha x. And this complexity arrived because of the modulus function. If there were no modulus function, then we need not to bifurcate it in the way. And for the modulus function, you should know how to deal with it. Okay. If you don't know, just search on YouTube that how to what is the modulus function, okay, for JE, and they will teach you that how to debunk it. So now let us apply the normalization constant, which says that whenever you integrate the wave function multiplied by with its complex conjugate, that is this and this, within the limit minus infinity to plus infinity, you get 1. And this is the exactly the real meaning, physical meaning should be there, that the particle must exist somewhere. Okay, so if the particle should exist, then its probability in all the space should be 1. Now we have broken this value into these two terms. For negative x, there is different value. For positive x, there is different value. So the integration will be also different. Okay. So look at here. So we are integrating. We are taking out n square outside, and we are integrating in between minus infinity to 0 this I1 with respect to dx, and the same thing for positive x values, and they all should give us 1. Let us take this n square in this side, and now we are left with this value and this value. Now let us put the values that psi1 square is going to be exponential 2x sine square alpha x dx. The limits are obviously negative x, that is minus infinity to 0, and for the same thing we need to do for the psi2. Okay, and it is going to be exponential minus 2x sine square alpha x dx. The limits are 0 to infinity. So now we are going to break this sine square alpha x dx, okay, and it is going to be 1 minus cos 2 alpha x by 2. Let me tell you that we have used one important formula here, class 11, that is sine square theta is equal to 1 minus cos 2 theta by 2, and for cos square theta you should remember it that it is 1 plus cos 2 theta by 2. So whenever you get the integration of something like sine square theta or cos square theta, you should always arrive at this. Okay. So from this we have broken into this format just by opening the bracket, and from this term we have broken it into the next term. And now our integration is very easy. We just need to apply the important formula. So what we got, when we integrated this and integrated this, we get collective term half, and for this term, which is going to be the gamma function, there is a ready-made answer. I will tell you how to write the ready-made answer, and this is going to be 1 by 4, 1 divided by 4 multiplied by 1 plus alpha square inside the bracket minus 1 divided by 4 multiplied by 1 plus alpha square, and this should be equal to 1 upon n square. Now we have everything as constant, so we now get our value of n, which is under root 2 multiplied by 1 plus alpha square divided by alpha square, which is our normalization constant. So finally, we get our normalized wave function, which is psi x, which is equal to under root 2 multiplied by 1 plus alpha square divided by alpha square and multiplied by our this given wave function, which was not normalized, which is psi, and this is n. Okay, so this is your desired answer. So the ultimate trick in normalizing lies down that how do you integrate that. And as we proceed, as we solve more number of questions, you will note that there is a definite pattern upon which the questions are being asked. Okay. So now let us solve this next question. So calculate the normalization constant for a wave function at time t is equal to 0 given by this value, and it is a exponential bracket opens minus alpha square x square by 2 exponential iota kx. And upon the same wave function, one pyq has been asked. So this is very important question. So, and it is also known as, this whole wave is known as Gaussian wave packet. Now we are required to calculate the probability density. We are first required to normalize the wave function, and suppose that a constant a which is attached in wave function is the normalization constant. So as per the normalization condition, we could write it in this form, that complex conjugate multiplied by the normal wave function in within the limits of minus infinity to plus infinity, when integrated would give us 1. This is our normalization condition. So when you find this value, that is the complex conjugate multiplied with the wave function, we actually get the magnitude of a square exponential minus alpha square x square. So we are integrating that only, and when you integrate that, you should remember that when you integrate the value which is inside this yellow highlighter, you get this answer. Okay, and I will again tell you each and every formula, but right now you should know that, you should memorize that this is going to be formula. We are not here to learn integration. There is a definite pattern onto which integration is being asked, and we are also allowed to use the calculator. So within the calculator, you can find the values. Okay. So in that, get that the positive value, that is modulus of the normalization constant, is alpha divided by root pi half, power half. Okay. So this is normalization constant. Now we are required to find the probability density. So right here, you should remember that the probability density is given by this value, that complex conjugate of the wave function multiplied by the wave function itself. So when you do that, there is only difference that sign of the iota is different. One is negative, then another is positive. That is what the complex conjugate basically does. So in that way, you just simply solve it and you will get that it is this value, alpha divided by root pi exponential minus alpha square x square. So this was pretty simple question. The only thing and that is big for us right now is this integration. So you have two options. The first option is to use calculator, but you could use calculator only in the case of limits, when there is a limit. The another important thing is that I will give you a definite list of results. So just use that. Now we are into the third question. The normalized ground state wave function of an electron in hydrogen atom is given by this value. Okay, the value is under bracket 1 divided by pi a naught cube whole power half exponential minus r by a naught, where a naught is nothing but first Bohr radius. The first thing we need to do that, we need to verify that psi is normalized or not. Okay, and we are now required to obtain the probability of finding the ground state electron at a greater distance than a naught from the nucleus. Okay, so let us do the first question. The condition of normalization is nothing but this value, that inside the space volume dv from negative infinity to positive infinity, okay, the value, the probability should be 1. That means the particle must exist somewhere. So you can write the volume element in the spherical coordinate system, because here the hydrogen atom is basically um, roughly spherical, and we treat it mathematically in spherical polar coordinates. So in that way, dv is nothing but 4 pi r square dr. So we have used this volume element, and when you integrate it, okay, you get 4 pi divided by pi a naught cube outside, as it is constant, and exponential minus r pi a naught r square dr. So what we need to do, we need to do some kind of mathematical trick, and the mathematical trick is whatever the power is given, that is exponential minus 2r by a naught. So assume that value to be something else. That now let 2r by a naught is x, and it is called method of substitution. Method of substitution. We are substituting some value for some another value. You can learn it from YouTube as well if you want to. So in that way, we got the value of r to be a naught by 2 into x and dr to be a naught by 2 into dx. In that way, we could write r square dr to be r square a naught by 2 dx. So when we use the equation 1 and equation 2 in the integration equation, our integration will be converted into the x term, and the x term is given by this. Okay. So you must note that because the radius is going to be from 0 to infinity, so our limits are from 0 to infinity. No, there is no need to take the negative to 0, because that does not exist for us right now. So now this is easy to integrate, okay, because we have a very important function as a result, and that is gamma function. So when you do that, you get exponential minus x multiplied by x square dx. Obviously, this value a naught by 4 is constant, and that is we are going to take it outside, and outside it will annihilate a naught square in denominator, and we will get just half, and we are left with the important integrand here, that is x square exponential minus x dx, and this is nothing but very important gamma function, and gamma function is here, we have written it. Gamma function is any integrand that is of this format, that is you get x to the power n minus 1 exponential minus x dx, then it is gamma function of n. So how in our case, what we have got, we have x square exponential minus x square exponential minus x dx. The limits are all the positive x, that is 0 to infinity. So x square is nothing but x ka power 3 minus 1 exponential minus x dx. So from here we got to know that n is 3. So this is gamma function for 3. N is equal to 3, and we have the established result for the gamma function. Gamma function for 3 is nothing but factorial 2, and factorial 2 is just the number 2, integer 2. So you just know that what is the gamma function. Remember some important values. Okay, that gamma function of half is root pi, gamma function of 1 is 0, 1, gamma function of 2 is also 1, gamma function of 3 is 2, gamma function of 4 is 6, and in between that. So here we got half multiplied by factorial 2, and that is going to give us 1. That means our given wave function was normalized. LHS is equal to RHS. Now we are going to obtain the probability of finding the ground state electron at a greater distance than a naught. from the nucleus. That is fine. So probability of finding ground state electron at a distance greater than a naught from the nucleus. So our integration limit now we know easily. It should be more than a naught and obviously less than infinity. So that is our lower and upper limit. And now again we are going to do the same thing, because for probability uh, we have the same expression. The only difference is that for the probability we have a defined set of limits that they are asking ki please find probability between this a naught and infinity only. If it were to be minus infinity to plus infinity, then obviously this probability is going to be 1. That is what we call normalization condition. Okay, but right now we are required to find it in between a naught and infinity. So again we are required to substitute something. So let us substitute. We have used here r is equal to x plus a naught, then r square, because here we have r square. Okay, so we need to do something for r square. So r square is x square plus a naught square plus 2x a naught, and then we will get dr is equal to dx. Now when we use this equation 2 and equation 3 in the integration, we get this value. And now it is simple to integrate. Okay, the integration is complex, but you will get it very easily. Okay, like here we can see that it is something which is in the gamma function format. Okay, so we got to do that, and we should must start feeling that whenever you get exponential something and then that variable itself, then it should something be in relation with gamma function. So you should manipulate that to convert it into gamma function. So what we do from here, we could think it like that. Okay, this is the gamma function exponential minus x multiplied by mm, multiplied by x to the power minus 1. So this is the gamma function. So we should try to make it gamma function. So what could we do? Here we should consider this power of the e as a single value z. So we have got uh, 2 a naught, 2 divided a naught dx as dz, and dx is a naught by 2 dz. So simply we are replacing all x terms to z terms. So using equation 4 and 5 we could rewrite here. Just notice that equation 4 and 5 is here when we are converting x into z terms. So we could rewrite the integral in this format as this format. Okay, it went from r to z. Okay, and now we have a definite format of gamma function. That is, here we have got one gamma function, here we have got another gamma function, and here we have got another gamma function. So here we had gamma function for 3, gamma function for n is equal to 2, and gamma function for it is just exponential z, so no gamma function. Okay, so in that way when you calculate, we know that gamma function for 2 is 1 and gamma function for 3 is 2. Okay, so in that way you have got this value, and therefore this value boils down to this value, and they all are the constants. So we could easily write that, and we know that a naught is nothing but 0.529 angstrom. This value, one should know that what is the value of the holes for the first radius, and e is nothing but Napier's base 2.718. So when you calculate using these all values, you get 0.6767. So in the percentage form, it is 67.67%. So in this all, there is nothing much important than integrating the given function. And for integration, here gamma function is very important. Whenever you feel there is something, some terms related to x and some terms related to exponential minus some constant x or whatever, so you must try to convert it into this gamma function. It will make your job a lot easy. Now we are going to solve this question. The wave function of a particle is given by psi x, and this value constant a exponential minus alpha x square, where x is something which lies in between minus infinity to plus infinity. A and alpha are both constants, so we need to calculate the probability of finding particles in between A and infinity. Again, the first job is to check for the normalization. So we have this constant A, and this constant should be normalization constant, and we are required to find its value using this equation. Okay, so when we put all these values, we got this, and this is again pretty easy if you know this value. Okay, so whenever there is something like exponential minus some constant x square dx in between the limits 0 to infinity, the answer is half under root pi by c. Okay, here our constant c is nothing but 2, so we did that, and in that way we got to know okay, this a square, this a square is nothing but 2 multiplied by root alpha divided by 2 pi, which is normalization constant. Now to find the probability, we have this equation and we just used it. We are going to solve it with this a square, because this is our normalization constant. So our probability is to be found in between 0 and infinity. So our limits are 0 and infinity, modulus of psi square dx. And let me tell you, this modulus of psi square is nothing but the same thing. We have done this earlier, so I think we are not required to make it clear again and again. So again we are required to make a substitution here. So 2 alpha x square, let it to be z. When you differentiate it both sides, you get 4 alpha x dx to be dz, and dx is dz upon 4 alpha x. So we substitute this value of x and this value of dx into this. Okay. So when you substitute, you get exponential minus z dz upon 4 alpha x from integrated from 0 to infinity, and we know the value of a square. When you do this, you get this value exponential minus half exponential minus z dz, and again it is gamma function of half. When you convert it, know that our gamma function is nothing but x to the power n minus 1 multiplied with exponential minus x dx. Limits from 0 to infinity is gamma function of n. So here n minus 1. So when you compare n minus 1 with the power minus half, you get n to be minus half plus 1, that is plus half. So gamma function of half is the answer, and gamma function with the value half is nothing but root pi. So we got this whole value as root pi. And now again it is nothing but a simple mathematics, and in that way you get to know that probability is nothing but half. So that particle has 50% chance to be found in between this limit, that is from 0 to infinity. And we are done with all the important questions, and I will attach a link with the same with this video in the description, that will give you the list of important integration ready-made results which you must remember for your purpose.